At 2:17 in the morning, an autonomous robot receives one command: move 20 crates to loading bay 3. It scans the shelf, calculates the grip, lifts the weight, takes 6 steps forward, and then stops. Then a single warning appears on a monitor: more compute required. Camera pixels must become numbers, numbers must become decisions, and decisions must become movement. A few miles away, a driverless cybercab approaches an unfamiliar intersection. A cyclist swerves into the lane. A truck speeds up from behind. The car has only a fraction of a second to predict both. The same warning appears: more compute required. Now move 500 kilometers above Earth. A future SpaceX satellite crosses the sunlight. It is just not sending internet traffic. It is trying to run AI compute in orbit. Then the same bottleneck strikes: more compute required. Those scenes look like imagined, but the engineering reality is not. AI looks like software, but the real intelligence is trapped inside the hardware. Every AI action follows a physical chain. Sensors capture the world, logic chips run the math, memory feeds information to the brain, advanced packaging connects the part together. If one link is going to get delayed, the physical world does not wait. A robot freezes, a car hesitates, a satellite stalls. Delay is going to cost money. Today, making that hardware depends on a supply chain spread across the globe. One company is going to design the chip, another is going to prepare the lithography mask. That mask is like a stencil for printing the chip's tiny patterns. A foundry is going to fabricate the logic. Another plant is going to pack the pieces together, and another one is going to test them. If a flaw appears at one point, the mistake is going to cost months before the design comes back. That delay is going to break the dream of a real-world AI. Robots and autonomous cars do not live in slow time. Training is where AI learns, but inference is where AI acts. Real-world decisions have to happen very close to the machine, and they should be very fast. This is why Tesla and SpaceX are planning a project called Terafab. It is planned for Grimes County, Texas. The target footprint could reach 100 million square feet. The first phase alone is expected to cost more than $16.8 billion. The headlines call Terafab a giant factory, but the real question is not about size. Real question is what Terafab is actually trying to control. Mass design, logic fabrication, memory production, and advanced packaging, all inside one closed system. Design the chip, build it, connect to the memory, test it, find the flaw, change the design, try again, without sending the whole process across the world every single time. The plan also points towards two different chip worlds. The first is for Earth, chips for Optimus robots, chips for autonomous vehicles, chips for machines that need instant decisions. The second one is fascinating. It is for space, hardware designed for satellite constellations, compute that could one day run above the Earth. Because SpaceX is not only thinking about data centers on land, it is also talking about AI compute in the orbit. Suddenly, Terafab stops looking like one factory. It starts looking like the beginning of a chain. Robot, car, data centers, satellites, and finally orbital chips. Now look closely at the construction footage from Texas. Foundations, heavy machines, concrete. It looks like the giant Terafab is already rising, but that visible site is not the 100 million square foot monster. That is ATCF, the Advanced Technology Chip Fab, a smaller research facility near Giga, Texas, the test chamber before the industrial giant. The real Terafab mega project is planned separately in the Grimes County. This is not a finished revolution, it is an attempt, and even the attempt has limits. Terafab is not total independence, it is kind of a leverage, and this leverage is actually around taking the control before the control takes back you. Because a chip fab does not live in the cloud, it lands in a real county. It needs reservoir water, power infrastructure, roads, workers, security, and local agreements. The digital revolution becomes industrial the moment it touches the ground. Now return to that robot standing in the dark. It is still holding the crate, not because the AI lacks intelligence. It is waiting because intelligence needs a body. Silicon, memory bandwidth, packaging, power lines, cooling pipes, factories, supply chains, and maybe one day rockets as well. Because the race for artificial intelligence was not about who writes the smartest software, it was all about who writes the machine behind it in the best intelligent manner. For the engineering reality behind AI hype, subscribe to NextGenQA.